Welcome to my YouTube channel, and today let's talk about Leetcode problem 430. So this is our problem. Here I will talk about two approaches. So let's do recursive first. What is the order that we have to traverse for this case? It should be 1, 2, 3, and then we go to the node below. So 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that is the order that we have to traverse. Here DFS should work. Now if you look at the graph problem like in Leetcode, it looks something like this, right? I captured this from Wikipedia, and so we start from node 1 here, and then we look at the neighborhood of 1. There will be 2, 7, and 8. So like something like this, right? You have a DFS of graph G will be this guy, vertex 3 will be this 1, and we come up with an array called visited, and we append this 1, and then for W in neighborhood of 1 there will be 2, 7, and 8, and if they are not visited we run DFS on this guy. So while this problem is not exactly identical to this graph, this structure, it is very similar. So instead of for W in neighborhood of 3, so instead of this for loop, we will have a while loop. So our node will point to this guy, and while node.next is not equal to none, we will keep moving to the right until we hit here. Then we will exit the while loop, and then we return. So looking at that example, how many DFS should we call? We have to call it 3 times. So first will be on this guy, and the second will be when we are at this node 3, and then the third will be when we are at this node 8. So we have to call DFS 3 times, and our DFS will run until our node will see null in the end. So let's look at this subsection and see how we can flatten this first. So to flatten this, we need 3 pointers. We need this node, we need the last node that points to this guy, and then the next node. Next node will be node.next. And so if you are given these 3 pointers, can you flatten this? Can you flatten this guy? So let's look at that part. And so last node will be whatever. So last node will be this guy, and that's the return value of our DFS. And so last node will point to this, our node. So we have to first we first have to connect this next to this guy. So they will be given by node.next equal to node.child. So that's 1, and then we set the previous of this 11 to 8. So they will be done by node.next will be node.next is pointing here, and then the previous will be pointing back. So that guy should be node itself. And then the 3, we set node.child equal to none. So here you see I whiten this out so you don't see it. So that's the key idea. And then we still have to think about connecting this last node to this guy, next node. But before we do that, we have to consider an edge case. So instead of this, what happens if you have just 8, 11, and 12? Well, 8 doesn't have the neighborhood. Well, 8 doesn't have anything to its right. So in that case, these 4 lines of code these 3 lines of code are sufficient. However, in our case, we have 9, where 8. So in that case, we have to do this part. We have to run the if statement to see if next node is none or not. If it is none, we skip. If it is not equal to none in this case, then we have to connect these 2 guys. So they will be done by last node.next will be this guy will point to this, and then next node.previous will be pointing to this guy. So that's what's going on. And then that's where basically in that case, so after this we basically flatten these two these two guys. And then our last node will point back to this node here, and then our node will point to node.next, that will be 11. Okay, so node is here, and then we will move to 11, and then we keep going to the right. And then when we hit this 10, well, we return this guy. We return this guy back. So let's run the code and see what we get. So here is my code for this problem, and let's run this. So there you go. And let's look at the iterative approach. So assume that we have a queue. So let's just create an array, call it queue, and then assume that each element in queue points to this node. So first element points to this guy, second element points to this guy, and our last element of this queue will point to this guy. So suppose you are given this, then it is very easy to flatten this doubly linked list. So how does that work? So we first create a dummy variable called previous node, prev node, and that will be pointing to this guy, the first element. And then our head will point to this guy by setting head equal to prev node. We will be running a for loop from 1 to all the way to the end, and our current node will be, so in this case, if I is equal to 1, then current node will be pointing to this guy, and this should be, sorry about this should be previous node dot next. Previous node was this guy, so previous node dot next will be pointing to this guy, and then current node dot previous will be pointing to previous node, so there's this one. And then we set the child equal to none, and we move the previous node to current node. So previous node was initially pointing at this one, but after we made the necessary connection, we move previous node from here to here. That's done by previous node equal to current node, and then you run it all the way to the end, and then you return the head. That will give you the answer. Now, so we assume that we had this queue already. So how do you fill this out? How do you fill this array? Well, they'll be done by this guy. Well, you will be running from here to here, and then if you encounter child, you go to the level below, and they'll be done. They'll be this guy. So if node.child is not equal to none, then you run DFS on this level, and then you will exit. And then when you exit, it should point to this guy. So there will be node equal to node.next, and then when you are at here, say when you are at here, your node.next is, well, empty. So in that case, you break the loop, and that should give you the answer. Okay, so this is our BFS approach. So this is our iterative DFS approach, and let's run this.